We're counting down the 11 most advanced humanoid and near-humanoid robots piloting real jobs today. From factory lines and warehouses to hospitals and hotel lobbies, these machines are fast outpacing science fiction, driven by breakthroughs in AI, agility, and lifelike expression. Ranked by real-world deployments, capabilities, and the all-important wow factor, some of these bots will make you rethink the future of work. Let's begin with number 11. Apptronik's Apollo enters the countdown as a factory workhorse, designed from the wheels up for real-world production lines. Rather than chasing spectacle, Apollo focuses on reliability and safety, traits that have landed it pilot programs with Mercedes-Benz and Jabil. At Mercedes-Benz's plants, Apollo is put to work on line-side delivery, inspection, and sorting tasks, operating alongside human teams in active production environments. Jabil, a global electronics manufacturer, is running Apollo through its paces on material handling and even using the robot to help assemble its own future siblings. What sets Apollo apart is its teleoperation to autonomy workflow. Skilled operators first guide the robot through complex tasks, logging data that trains Apollo's AI for gradual handoff to full autonomy. This approach shortens deployment time and helps ensure safety in mixed workspaces. Apollo's modular actuators, swappable joints that can be reconfigured for different jobs, make it adaptable across tasks without a full redesign. Safety protocols and human oversight remain central, with every pilot trial closely monitored. While Apollo's scale is still limited and its appearance less headline-grabbing than flashier bots, its presence on real factory floors signals a practical, measured start to the humanoid revolution. Digit, from Agility Robotics, steps onto the warehouse floor with a clear mission: to move beyond pilot projects and into mass production. Unlike earlier robots limited to single-site trials, Digit's bipedal design is tailored for the human world of logistics, navigating aisles, lifting totes, and working safely alongside people. Amazon's 2023 trial in Houston put Digit to work recycling containers and moving bulk materials, collecting data on how the robot could handle real fulfillment center demands. Early feedback from workers ranged from cautious curiosity to outright concern, especially after a near miss in a busy lane triggered a temporary pause and a round of safety upgrades. But the bigger story is scale. Agility's new RoboFab plant in Oregon is built to produce up to 10,000 digits per year, aiming to supply not just one or two warehouses, but entire fleets. The company's vision is to make robots an everyday presence in logistics, not a novelty. That focus on volume is what earns Digit its spot at number 10, setting a new bar for ambition in the field. Figure 01 stands at the intersection of ambition and investment, an American humanoid with its sights set on the heart of the auto industry. In early 2024, Figure signed a commercial agreement with BMW for a staged rollout at the Spartanburg plant, one of the largest car factories in the United States. The plan? Deploy Figure 01 as a logistics assistant, moving materials across the plant floor and eventually supporting assembly tasks. This partnership did not come cheap. Just months before the BMW deal, Figure announced a staggering $675 million funding round, drawing investors from across Silicon Valley and beyond. The company's early collaboration with OpenAI promised to push robot reasoning to new heights, though Figure soon pivoted to develop its own in-house AI stack. Inside BMW, the arrival of Figure 01 triggered heated debate. Union representatives demanded guarantees on job security and retraining, while executives weighed legal risks and compliance. Every move was scrutinized, every contract clause negotiated. For Figure, the high-stakes dance with BMW is a test of both technology and trust. The scale of capital involved signals that the race to humanoid dominance is now as much about resources as robotics. At number 9, Figure 01's story is less about what's already accomplished and more about the enormous bets being placed on the next leap forward. Unitree's H1 doesn't just walk, it sprints. In 2023, this full-size bipedal robot set a world record, reaching 3.3 meters per second on a straightaway, with engineers claiming it could break the 5 meters per second barrier in future tests. That kind of speed isn't just for show. It's a direct challenge to the idea that robots can't keep up with the pace of real factory work. Under the hood, the H1 is packed with high-torque motors, a reinforced frame, and a sensor suite that rivals some autonomous cars. 3D LiDAR and depth cameras deliver a 360-degree view, allowing the robot to track obstacles, map its environment, and even execute flips or rapid gates across cluttered floors. But the real shock comes from the price tag. Unitree advertises the H1 for less than $90,000, a fraction of what rivals typically charge for similar hardware. That aggressive pricing isn't just a marketing ploy, it's a signal that high-speed, human-scale robots are about to become accessible to a much wider range of buyers. For now, most H1s are still in research labs or controlled demos, with reliability and field hours yet to be proven. Still, the sheer mechanical leap and affordability put Unitree H1 at number 8, setting a new bar for what's possible in humanoid locomotion. A mecha, engineered by the UK's Engineered Arts, stands apart from the crowd of industrial robots with a face built for conversation, not heavy lifting. Its head alone contains 27 independent motors, each one controlling a micro-movement in the eyes, brows, lips, and jaw. The result is an android capable of subtle expressions, a raised eyebrow, a hesitant smile, even a fleeting look of surprise. Stereo cameras, directional microphones, and advanced face tracking let a mecha lock eyes with a person, follow speech, and react in real time. Paired with conversational AI, it can hold a dialogue that feels, at moments, disarmingly human. But the effect isn't always comforting. A mecha's expressiveness walks the razor's edge of the uncanny valley, where the line between lifelike and unsettling blurs. Designed not to walk but to interact, a mecha is a fixture at expos, tech demos, and media events, showcasing what happens when robots are built not just to mimic our bodies, but to mirror our emotions. Its presence in the countdown signals a widening of the field. Robots are no longer just tools for repetitive tasks, they're entering the realm of social interaction, where the impact is measured as much by public reaction as by productivity. A mecha earns its place for cultural resonance, even as its labor utility remains limited. Inside a factory in Dalian, China, a different kind of android takes shape, one measured not by how many bolts it can tighten, but by the uncanny realism of its face. EX Robots specializes in hyper-realistic android heads, each crafted to order and delivered in as little as 2 to 4 weeks. The process blends artistry and engineering. Silicone skin is tinted and textured by hand, while dozens of micro-actuators are embedded beneath the surface to control every eyebrow twitch, lip curl, and eye movement. These tiny motors, often no larger than a grain of rice, let the android mimic human expressions with a subtlety that can unsettle or amaze. Clients range from theme parks and museums to high-end exhibitions, where the line between performer and machine blurs for visitors. Pricing reflects the bespoke nature of each build, typically between 1.5 and 2 million yuan, or about $207,000 to $276,000 per unit. Unlike a mecha, which prioritizes expressiveness, EX Robots focuses on realism. The goal is to create characters that can pass for human at a glance, whether greeting guests or starring in immersive installations. The company's rapid build cycle and custom approach have turned the Dalian facility into a boutique workshop for the world's most lifelike androids. But for now, the market remains niche. Each head is a feat of craftsmanship, not a mass-produced commodity. That blend of speed, realism, and exclusivity secures EX Robots its spot at number 6, as the countdown pivots from mechanical prowess to the business of synthetic identity. Fourier Intelligence's GR1 enters the countdown as a new breed of humanoid, one designed not just for factories, but for the demanding world of healthcare and rehabilitation. At 1.65 meters tall and weighing 55 kilograms, GR1 is engineered to handle up to 50 kilograms, making it capable of assisting with patient transfers, therapy exercises, and even light logistics in hospital corridors. What sets GR1 apart is its approach to perception. Instead of relying on LiDAR, it uses a camera-only 360-degree vision system powered by a transformer-based AI stack. This bird's-eye view mapping, combined with occupancy networks, allows the robot to navigate crowded, ever-changing environments, like hospital wards, while maintaining a detailed awareness of people, beds, and equipment. In 2024, GR1 began mass production, with pilot deployments in Chinese hospitals and care centers. These trials quickly drew attention from regulators and privacy advocates. At Shanghai's Ruijin Hospital, the robot's 6 RGB cameras recorded and stored footage locally for system review, triggering a city health audit after a whistleblower flagged unauthorized data access. Fourier responded with a software patch to tighten access controls, but the episode underscored the delicate balance between technological advancement and patient privacy. GR1's ability to operate in sensitive, human-centric spaces without the bulk or cost of LiDAR demonstrates how vision-first autonomy is reshaping the service robot landscape. Its deployment in rehabilitation and elder care highlights both the promise and the complications of humanoids working side by side with people who are often at their most vulnerable. For these reasons, GR1 stands at number 5, bridging the world of entertainment androids and the functional service robots now entering our daily lives. Kinon's X-Man R1 steps into the spotlight as a service humanoid designed not for the factory floor, but for the bustling lobbies and corridors of hotels, restaurants, and logistics hubs. Unveiled on March 31, 2025, the X-Man R1 is more than a standalone robot. It's the coordinator at the heart of a multi-robot ecosystem. In real-world pilots, X-Man R1 works shoulder to shoulder with Kinon's delivery and cleaning robots, orchestrating a seamless flow of tasks that once required an entire team of human staff. Its multimodal perception stack, combining cameras, microphones, and touch sensors, lets it navigate dynamic spaces, recognize faces, and even interpret guest gestures. Front-of-house duties range from greeting arrivals and guiding guests to their rooms to answering questions and relaying service requests back to the kitchen or cleaning staff, all while keeping tabs on the status of its robotic colleagues. In a typical hospitality pilot, X-Man R1 might direct a cleaning robot to a spill, dispatch a delivery bot with fresh towels, and check in with guests, all in the span of a few minutes. This level of coordinated autonomy is a leap beyond single-task robots, offering a glimpse of how future workplaces could function as tightly integrated human-robot teams. The X-Man R1's proven ability to manage and synergize a robotic fleet is what elevates it to number 4 on the list, setting a new bar for systems integration in service environments. In Japan, the android known as Erica has become a cultural touchstone, not for her mechanical prowess, but for her presence in the public eye. Developed by Professor Hiroshi Ishiguro and his team at Osaka and Kyoto universities, Erica was designed to push the boundaries of human-robot interaction. Her most famous moment came in 2018 when she delivered scripted news segments on NHK, Japan's national broadcaster. These appearances were more than a technical demonstration. They became a national conversation about authenticity, trust, and the future of media. Producers debated whether Erica's calm delivery and subtle gaze would attract viewers or leave them unsettled. Focus groups reported a mix of curiosity and unease, with some participants forgetting, after a few minutes, that they were watching a machine. Erica's creator, Professor Ishiguro, fueled the debate by declaring, "Erica has a soul because she has her own intentions." He argued that her sense of self arises whenever her algorithms decide how to move and respond, challenging audiences to reconsider what it means to be sentient. This statement was not just philosophical theater, it sparked a wave of academic and public scrutiny. Human-robot interaction studies soon followed, measuring how Erica's gaze timing and conversational pauses affected people's comfort and engagement. In controlled trials, subjects rated her adaptive eye contact and context-aware speech as remarkably natural. Many reported that Erica's presence felt compelling, even comfortable, despite knowing she was powered by lines of code. Erica's journey from laboratory prototype to media personality has made her a symbol of the new era of androids. She stands at the center of debates over synthetic identity, agency, and the boundaries of human likeness, raising questions that go far beyond engineering. Her legacy is not just technical, but cultural, a reminder that the arrival of humanoids is as much about our willingness to accept them as it is about their ability to perform. Deep Robotics X30 stands as the outlier in a lineup dominated by human-shaped machines. This four-legged robot isn't built to mimic our form, it's built to survive where most humanoids still falter. With a top speed over 4 meters per second, the X30 moves with purpose across factory floors, utility tunnels, and disaster zones. Its design is all about resilience, IP67. Certification means it shrugs off dust storms and can wade through a meter of water without missing a beat. The X30 keeps working in temperatures from -20 up to 55 degrees Celsius, making it as comfortable in a frozen warehouse as in a sweltering power plant. What sets the X30 apart isn't just its shell, but its mind. The robot's autonomy stack is tuned for survival. It doesn't just follow a path, it adapts on the fly, using a fusion of LiDAR, depth cameras, and infrared sensors to see in pitch darkness, blinding glare, or shifting shadows. In real deployments, the X30 demonstrates self-evasion. It senses when a person or object approaches and plots a new course, dodging rolling carts or sudden obstacles without human intervention. This behavior isn't a party trick, it's a necessity for robots working shoulder to shoulder with people in unpredictable environments. In Singapore, the X30 patrols over 40 kilometers of underground power lines, inspecting for cracks, leaks, and hazards that would put human crews at risk. Its quick-swap battery keeps it running for up to 4 hours per charge, covering up to 10 kilometers in a single shift. Over 600 industrial and emergency scenarios have tested its limits, from collapsed tunnels to chemical spills. The X30's ruggedness and autonomy are now the benchmarks that bipedal robots must meet before they can claim a true role in the world's most demanding workplaces. While its form may be different, the X30's reliability is a glimpse of the standards all future factory robots will have to reach. At nearly 1.72 meters tall and weighing 76 kilograms, UBTECH's Walker S1 stands as the clearest sign that humanoid robots are crossing from lab experiments into real industrial work. In late 2024, BYD, one of China's largest automakers, began training Walker S1 units on its electric vehicle lines. The robots handle repetitive, physically taxing jobs, carrying parts, transferring crates, and performing quality inspections that once depended on human eyes. One standout task: Walker S1's ability to detect air conditioning leaks on the assembly line, using its integrated vision and sensor suite to spot problems invisible to the naked eye. With a payload capacity of 15 to 20 kilograms, these robots are built to haul heavy components across sprawling factory floors, working alongside automated guided vehicles and human supervisors. While UBTECH has announced pilot deployments at other major names, Geely, Foxconn, Audi FAW, and IO, most of these remain in the training or apprenticeship phase, with only Dongfeng Liuzhou Motor confirming a public order of 20 units. Claims of hundreds of intended orders circulate in industry reports, but no automaker beyond Dongfeng has published evidence of large-scale procurement. Instead, Walker S1's real impact is measured by its presence across multiple high-profile factories, where it is tested on logistics, assembly, and inspection tasks that demand both endurance and adaptability. Performance metrics released by UBTECH highlight a 99% accuracy rate in visual inspections and a 25 to 30% improvement in operational range and speed for the latest models. These figures, however, remain self-reported, with no third-party audits or independent validation available. On the ground, pilot deployments have encountered typical teething issues, occasional mapping errors, minor collisions with carts, and emergency stops after dropped tools. Each incident is logged and followed by upgraded geofencing and stricter emergency protocols, reflecting the cautious, step-by-step approach factories are taking as they integrate humanoids onto the line. For China's manufacturing sector, Walker S1 is more than a technical demonstration. It is a test case for whether humanoid robots can shoulder the relentless pace and complexity of real production. The robot's ability to blend into existing workflows, perform multi-shift duty, and coordinate with both people and machines is what sets it apart. While mass adoption remains on the horizon, Walker S1's multi-site pilots and expanding task repertoire make it the most advanced candidate for bridging the gap between demonstration and deployment. Its story is not one of hype, but of measured, incremental change, each shift on the factory floor bringing the silent revolution closer to reality. From factory workhorses like Aptronic Apollo to the uncanny realism of X-robots, and culminating with China's UB Tech Walker S1, already training at BYD, this countdown shows just how fast humanoids are moving from lab demos to real-world jobs. Across all 11 entries, the most surprising pattern is the acceleration of large-scale pilots. Multiple robots are now deployed in auto factories, warehouses, hotels, and even on TV, not just as tech showcases, but as staff replacements. What set the top-ranked bots apart was clear evidence of deployment, practical capability, and orders in the hundreds, alongside the wow factor of lifelike design and autonomous behavior. The broad takeaway: this category is no longer defined by prototypes. Humanoid robots, especially from China, are now competing head-to-head in global industries, reshaping what it means to work in a human-built world. The silent revolution isn't coming. It's already clocking in.